Okay. So, okay, again, like I mentioned, all right, this, if you've written a code like this, it looks nice, it looks as if it's working, everything's okay. Yeah, but this is just shows that you just want to get an answer, right? You don't really care about, you don't think about the edge cases. Okay, even an interview, right? It won't be accepted. It gives you the answer, but it won't be really accepted. So if somebody that really write it better is there, you prefer the person, yeah, because this is something that can easily just fail. Okay, because if I change this by mistakenly, if I just by mistake, I do this, that could just be the end of the program. Okay, you can see it gives me type error. So there's even no way for somebody using this that it may be present to the person, oh, I have written this function, good. And then the person starts using it. Oh, you can use it. It will give you the square root of a function anytime you use it. So you don't need to start to implement form. Yeah, but of course, I mean, this is not enough. All right. So first of all, you need to write it in a matured way. Okay, let's start with the doc type. Okay, the doc string. Sorry, I say doc type. Okay, so you need to describe what the function does. Okay, the square roots using. Okay, in this case, the method I use it's called the method. Don't need to worry about the name. It's one guy. I don't know which century, maybe 16th or 15th century that came up with this. The method of Heron, I think Heron Alexandra. Okay, that's a method. Like I mentioned, I mean, nobody will tell you to code up this thing without looking at it, describing the algorithm for you. Okay, it's a standard kind of algorithm. So, but it's just also good for you to really state it, because we also have Newton-Raphson method, so that we know the method we're using. There are certain methods that are much more efficient. Like that Newton-Raphson method is a bit more efficient. If you have done computational and numerical analysis in mathematics before, or if you remember, you must have done it. But if you remember Newton-Raphson method, yeah, you know that it's a bit more efficient, because that one now will now give some epsilon range to tell you, say that, okay, as the value converges to epsilon, maybe some approximations. So that one is a bit more mature and a bit more, yeah, but this one can quickly just give us the answer. Yeah. So the next thing you need to do here is also you need to write out, give a bit more information about this. Okay. So let's see what information we can give here. So also you will see that we are accepting some arguments. Okay. So I'll just say X. Okay. The number for which, no, if you are writing your code, right? If you are writing your own code that you put in your laptop, you don't need to put all this, right? But if you are working in a team, or you are writing, this is more like you're trying to write an API that does not exist there. So you need to describe it, is to be the number for which the square root is to be computed. Okay. Okay, and you know that other people are going to use this code, or when you leave that environment, people would also use the code. Returns what returns the square root of X. Okay. Again, why do we write this? Now, let me show you how important writing things like this is. Okay. Right. So why do we write this? Okay. So the first thing I'm going to do here is to comment out this. All right. And spin up the Python shell. Okay. Now, if you've written it and somebody wants to use it in another program, this is what the person will do. The person will say something, okay, I did not save it, so I need to go back and exit and then come in again. Yeah, make sure you always save it before you spin up the Python shell. Okay, so I'll just say Python. All right. So if somebody is going to use it, this is how the person will use it in his program, in his or her program. Okay, you'll say from exceptions. That is the module where the code is located. Some exceptions import root. Okay, of course, it does not give me any error because that's Okay. Now, if I say root 9, of course, I expect them to give me 3.0. If I say root let's say 45, of course, I expect to give me the right answer. All right. If I say root 100, okay, I expect it to give me the right answer 10. Okay. Now, why did I put all this doc type, right? See what happened now. If I say help root to find out more about the API I've written, you can see it has given me all the things I've written up here. So quickly, the person does not see this code. The person will not see this code. The person does not know that this thing exists. He will import it or she will import it, and then can quickly find out more about the stuff. Okay, I'm supposed to have written this in here. So by not typing help in Python shell, the person could really see. Now that's the essence of us also always putting this thing, so that if somebody is going to use it, the person can quickly find out information about it and then now know what to do or how to handle it. So, but in this case, even we haven't handled exceptions. Okay, so even if there are going to be some exception, what happened here if I do root is 90, and then it gives me exception, and then my program crash. Can't multiply sequence by non-int of type string. Okay, it's a type error. It's not expecting that type. So what I can do here to solve this problem is to actually tell the person that this thing is going to raise an exception. Okay. So how will I do that? I'll say, I'll come here and add here and say raises. Okay. The exception that I will expect, like this case, we have a type error. So let's start with that. I'll say type error. Type error. And that is if X is not of type int or float. All right. So it should raise that error if X is not of that type. Okay. But then how do I then incorporate this into the program? Okay. How do I then incorporate this into the program? Again, it's not difficult. Okay. So what we need to just do here is to now write a code. So just add some more things here. So how do I handle this? How do I raise this exception? So instead of just going through to start guessing and all of that, I need to now start my code like this. I'll say if you can do it different ways, like, but I need to check if this value that is being given to this function is of type int or float. So how do I do that? I'll say if instance, now take note of this, right? If instance of x is not one of these, int or float. So if you are given two values, right? If you want to test for, if it's just one value, you can just say int. So what I say that if instance of x, that instance of this value, whatever, is not an integer. So if you, of course, we want to also handle float. So if it's not an integer, comma, or float, what should happen? Okay, what should happen? I want to raise type error. And then and tell the person that x must be an int or float. Okay. All right. I can also go on and say, okay, let's look at, okay, yeah, let's just write another one at once so that we can just tell the person that, okay, so of course too, you can you find a square root of a negative number? You cannot, so you can also quickly just do that. If x is less than 0, all right, you can quickly just raise an exception. What's the exception? In this case now, is a value exception. So because 0 or negative value is an integer, a negative value can also be float, but it's not the type of value they are looking for. So the type is correct. That's why it's not raise a type error. But in this case now, it's not going to raise a value error. So when I say S can not be negative. Okay. So That's it. So I would then have to come here and say, say what? I would then have to come there and say F. So there are two types of exception is raising. Okay, here I would then come here and say value error if X is negative. So in this case now, F is already the type of value, but it's not it's already the right type in this case, but not its value. It's not the requested required value. So now let's now kill this. This is it. Just clear, and then bring up this again. Of course, this thing I'm writing here is also very, very discouraging. We're not supposed to be writing our code. When we're testing our code like this, we shouldn't be writing our code directly in a global scope. So this is called a global scope. So I'm writing outside of any function, right? So usually, but we're going to go deeper into that. But whenever you want to test your code in a module like this, always write it inside this. Of course, we're going to explain what it means later on. Okay, and we're also going to see how it's not a good thing to do. Oh, sorry, I'm not doing JavaScript. All right. Okay. 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 So here now, let's try to test this code again and see what happens. Of course, it should raise an exception. And then the exception now is you can see from the message of the exception now, that is exactly what I described. I stated in the say X must be an int or float. So you can see you've been coming across type error where they give some information. Now when you're writing your code, you have to also be able to write code, especially code that is going to be used by someone else, right? Also write code to make sure that you can have or raise a type error that actually give you this kind of information. So this is how they actually get it, so raising error. So now somebody that's now using, let me now act as a user of this function. So acting as a user of this function now, I won't just use it like this. Okay, I won't have to do this. I will instead use the function like this. Try that. Okay, except, and then because me I already know about the function, right? Except, and now we're going to handle type error and then value error, because that's what the two things that this thing returns to me. Okay, so in this case I will not do, just to make it easier for me for now, I don't do root equal to -1, like in the case where I do not get the right value. So now you as a user now, I'm now using this function that someone else has written. Okay, so this is now how I'm going to handle the function. This is how I'm now going to use it. So I won't just dump it right there. I need to, because I may also want something to happen. Like this case now, I want something to happen here. Okay. All right. I may even want something to still happen here for I in, or maybe let's just say I want to just even print out something like this list range. Maybe a list of values starting from say 0 to 10. Okay. I maybe want to like just list out this after executing this. So let's now see what happened in that case. Okay. So let's see. All my program is working. All right, because the exception is handled and it allows the thing to continue because I've now written the program correctly. And then here now I can even change it to maybe 0.45, and I won't have any issues at all. Okay. Again, you can see. Or let me run it again. I have enough space on my screen. Okay, so it gives me that value. Okay, so do you understand what's going on here? This is very important. Why I'm repeating it now is like you need to now start writing your code in a matured way, and not just dumping out things there. And you're also thinking about different scenarios. Okay, and of course, I know most of you must have come across something like this. Just basically just testing, and we use this in advanced code. We use this a lot. This instance of just trying to check the values. Okay, it's very important. So you are not basically. So what we're saying that if not, so if S is not instance of this, well, you can also write it the other way around anyway. Okay, but it makes more sense to just put it like this. So you want to now raise error. So you now imagine in this other one, you have to they must have written something like that where they raise an error. So as long as these values, errors are not raised, that is the only reason why you should even compute this. So you don't want the computer, you don't also want to put the computer in a situation where the computer is doing something that will not work. All right. So that's why you need to handle whatever input case that is there, that is given. All right. And then before you can do that, I don't know whether I will have time to now go through, because I planned for us to also go through some other concept like iterators and so any question so far? Any question? But we may not really have the time for today. We may have to just continue it next time. But just try and start doing the exercises also, because when I see your code, when I see you exercises, the question has exercise. So I don't want to be seeing those kind of code that will be written in the previous book that we using before, right? So and I want to see a matured, well-structured code. So even if the question may be very simple, okay, so write it as if you are writing code that will be used in production, that will be approved, that this code should run, or that this code should be put in a plane that is flying in the air so that the plane will not encounter any exception and fall from the sky. Okay, so let your code be robust.
So I have one question.
Yes, please.
So like an example where you use under the not instance where you said raise value error.
Yeah.
What if it's supposed to give a value error, but you put raise type error instead? Does it override the value error that when it's giving you the error message?
Yeah.
Will it override the type error that it's supposed to give because you wrote raise well, in this case, it's meant to be value error. So I'm assuming you wrote raise type error instead. Will it override the value error or will it correctly say it's meant to be a value error?
Okay, so you see, both of them are mutually exclusive, right?
Yes.
Yeah, as you can see from this. So when you have if not, okay.
Yeah.
So if not, the first if statement is testing the type error. So if an error is raised there, it will not continue. If elif is not going to take place, right? Did I answer your question?
Yes, it does.
Yeah.
It does.
So yeah, in the case where, remember this value error, if the program control comes to here, it means that the type is actually the right type. So it can be integer, it can be string. But in this case now, it's just negative. So that's the only reason why this will be raised. Okay. But always make sure, have this in mind when you're writing production code, right? Have this in mind that people can so don't always believe that you code you are writing, they're going to use it the way you intended, right? So you need to be able to handle in case of in fact, if you're writing network programs, right, in that case now you also need to handle errors due to network. Like in Nigeria, they used to take light, in fact, and have you not seen a situation when if they take light now and then I quickly switch to, let's say if I have two networks, like one is based on a constant power supply, another one, let's say my MTN and this other one, and quickly switch to sorry, I have two different internets, like we take light and then one goes off, right? The Zoom will go off quickly, and then it will still come up when it catches the other internet, it will still come up.
Yes.
Yeah. So even if there's a break in transmission, all right, a break in the network, in the internet connection, say it still come up, it does not crash the program. I'm sure Zoom it has happened to you when there's a info, it will just go up and then come up again, because in the program the network has been handled as in the form of an exception has been raised and it was handled well. So that's the only reason why it comes. Otherwise it will just crash because they're taking like all the connection has disconnected. So that's why it's are you raising your hand, or was it previously?
Yeah, it was raised. Let me lower it. Thank you.
Okay.
Yeah, thank you.
Yeah. So yeah. So that's how you need to. That's why in your program you need to always think about these things and not just write code. And yeah. So all those ones that used to work, or you just work, you get the answer, is fine. I mean that's why we don't really, even when I review. Remember when you were doing all those exercises, I review it. There are so many things that I saw there, but the idea is for you to gain the right foundation of computational thinking. So I'll be able to now understand this All right. So yeah. So any more questions regarding this? Because we're not going to come back to exception again. We have to just move forward. Right. We don't have to, and probably we may not come back to this docstring again. So you also know, so it's important. Okay, let me run the docstring again so you now see how clear the whole thing would be. So imagine you are the one now that trying to find out more about the code. Okay. So the reason why I put this here also is that if I don't put it and I import, see what will happen. Let me show you something. Okay, but I will explain it later on in a better way, in a more clearly. Okay, so what I'm going to do here is to, sorry, what I just do. What is? Okay, this. Okay, so I'm just going to remove this if statement. Okay, just to show you something now. So you see, I'm testing this here. So normally when you write a module, under the module, you need to write test unit tests. So all this module you are seeing, all these square roots, under they also always have unit tests to test it. Okay. So and they also use that, they don't use to clean it, they also remove them. Because if some error happen in the future, you need to go back to this unit and see whether anything is wrong, or you even add more unit tests, right? So those unit tests will not be seen by the person using the program, but it's just for you to see if there's any error in your code. Okay, so let's just put it like this. Let's say, imagine that we just put on the global scope like this without and then try to do something for now. Let's just do Python exception, right? Of course, it's run. All right, it's properly handled. Okay, let's just even use maybe this one. Okay, and do this. Okay, it gives you the right thing, right? That's fine. Now let's go and do this. So Python share, and then imagine I'm using this in a program, and I do this from exceptions import roots. See what will happen. You see, it executes this code, and this is not the intention. I want to just use this root here. I wanted to use the roots like this, but already it has already executed this code. Which is not, imagine when you have to import something and then the code to execute, you get even confused, say, wondering what is happening. I begin to do what is happening. It's because some code has been used, which was used to test the function, was written on the global scope. So whenever you import it, that could be executed at all times. Now let's now go back to how it was before now. Okay, by putting it inside this statement, I will see change it to 34. Okay, so I'm just going to leave this and come back to it again. So I'm just going to clear and come back to it. And I'll say import. I'll say the same thing from exceptions import root. And you see, it did not execute the code because this is saying that execute this only when you are calling the code like this. Only when you are calling the module or the function like this. That's only when this should be executed. Otherwise, if you are calling it in another program, you're importing it in another program to another program, no, don't execute this. So that's why it's important you always write your code, testing code inside this statement. So we're going to go to really understand what this means later on. Okay. So because of time, I have some place our location I want to go today, so I will not be able to continue. But okay. So this one, but with what we have learned so far, try to solve those problems. Let's see how you are now begin to approach your code, how you begin to structure your code in a different way. Even if some of the problems are very simple, but don't just write it. Think about the problem very well and see how you can approach it in a different way. So just let's say just very briefly, okay, about what's it called, iterators. So iterators are very, they are very important concepts in programming. If you don't know how to use iterators, some of the codes you'll be writing, okay, will not be as much efficient as it's supposed to be. Okay, iterators help you to, okay, for instance, because of iterators, we're able to do something like this. Okay, who can tell me the difference between these two things I'm going to write? I will say, I'll just call it numbers equals just say numbers equals just say I for I in range 10. So what would this give me? What will it give me? Anyone here?
I should give you 0 to 9.
Okay, 0 to 9. Yeah. So let's see.
Yeah.
Okay, we don't have much time again, but we'll still be anyway. So let's say 0 to 9. Let's say I'll just call items. Fantastic in the list. Okay. Now let's look at the second one. So what will this one give me? Or do you know there's a difference between the two of them? Okay, let's just run it.
I think 9 to 18.
No,
it
give me a generator.
Oh. Okay, yeah. Oh, he put the brackets. I thought it was selling. Oh.
Okay, yeah. So it gives me.
Yeah.
I'm sure you must have come across something like this before. Maybe when you put.
Yeah.
Yeah. So yeah. So this is what it gives me. And what actually this means that the one that is more efficient, this one is more efficient.
Yeah.
Because a generator will generate the value as needed, one at a time. So it will not store everything in the memory. So in terms of memory, this one is least more efficient than this. So this one now already taking a space in the memory. Why this one now taking all this space to put all these values? Why this one now will just have a pointer to one particular place in memory? So if this one take like 10 spaces in memory, this one taking only one. Okay, so this knowing about it also will make us think about, we're able to think about how we can write our code in a more efficient way. Okay, and how do you now get the values here? So one way to even get the values here, there is a function called nest in Python. It's only not in Python in most of programming language when it comes to iterators. So let's see the first value in numbers. So to get the first values in these numbers too, all I just need to do is to do something like this. Nest. Yes. So put that in this function called nest. And it gives me the first value. Or the first value 0. So if I print this a couple of times, nest. So you can see it gives me 4 values. Okay, so it only generates the value, that's why it's called generator, as needed. So and then we have a generator. One of the generators we've been using by default is that for loop. When we are using for loop, what is really happening there is that we are using a generator implicitly. Okay, so automatically, because you don't take control of the numbers that have been generated from the for loop, from the range. No, you don't. Okay, it just automatically. So there's something that happened that makes that possible. So we also want to, what if I want, like in the program, you can say this one will always give you range in Python, always give you numbers between integers, right? Is it not? Are you with me?
Yes, yes, yes.
So if I do something like this, let's say I do something like this, 1 and to 10, and then I want the value is 0.2. So what do you think this will give me? If I have step of 0.2, what do you think it will give me? Have you tried it before? Or you just imagine that the value.
We tried real number, not in decimal numbers.
Exactly.
Like this.
Now it gives me what? A type error, an exception, float. Cannot be interpreted as an integer. But in some cases in the real world, we need values that are separate, that are ranged with integer. So in that case, what do we do? When we now, that is what you want, but you cannot get it. Well, how then will you get it? Will you just say, oh, I don't, we can't implement, it's not possible. Okay, you can't just say it's not possible. Oh, we cannot do everything that gives. No, you don't do that. We don't say it's not possible when it comes to programming. But quickly, we're going to look at it later on. But let me just quickly show you something so that to know that it's not that you always just depend on the libraries provided to you by Python. You have to sometimes, depending on the problem you are trying to solve, sometimes I have to create a simple library. Let's say I'm going to just create something that will help that one to work. All right, I'll just call it frange. That will still have like start, stop. This will be the last one to do, and then increment. Okay, because that's the increment, isn't it? This one's the increment. Now, but then how do I do it? So I'll just say start. So it's going to start from whenever it's printing, whenever I'm calling this range, it's going to be printing from the start. And then I'll now say for okay, it's better to use while loop here. Y x is less than stop. Okay, so we want to make sure that it's less than this, just as the way the range for works. Okay, I want to now yield, and this is why the generator comes in. So we're going to this what I'm writing here is actually not a function. All right. So whenever you have a yield statement, right, it's not a function, it's called a generator. Okay, so even if we start with div like this, it's not a function. Okay, but we're going to go deeper later with it. So now say increment. So whatever increment it is, it will just work for me. So here now, I'm going to just take the same thing here now, right, and use it here and see what will happen to this program. So I'm just going to just copy it and comment it out. And because since Python did not give me, so I decided to create my own. And then, yeah, let's see if it's going to give me what I expected. Okay, so Python did not give me this, so I have to create my own. So if I don't know these tools that I can, Python will provide certain tools. Like this here is not only in Python. So if one thing about programming language, you can always, like if you JavaScript, you can quickly write this thing in JavaScript as well. It's not a problem at all. So just to understand those concepts, you can always we have generators in C++, although that one is a bit more involved anyway. But yeah, this is going to work. Hopefully, let's see. Sometimes I have to say hopefully to see whether it's going to really, really work. So what do we have here? Let's see. Let's equal to. Why is it giving me that? Okay, so let's run it and see. Python, what? Okay, it's not running. Cannot be interpreted as an integer, and that because I have not saved it, so it's still running the previous one. So let's try again. You can see that's the range. So in the factor of course, you have some funny stuff there, but you can see that it's now giving me values in 0.2 range of 0.2. So the first one is 1, second one 1.2, 1.4, this 1.6, 1.8, 1.10, 2.19, and so on and so forth. Okay, so these are tools that you can use to create, so that you don't say, oh, there is no solution. Okay, there is no, it's not possible, or it's this, that. Okay, let me just make it so I just look a little bit nicer. Okay, let's just do it like this, because these values are looking a bit more uninteresting. So I'll just start with 0 and maybe to 4, so that we can have just less values, and then maybe change this to 0.5. Okay, so I'll clear again and run it, so it will be even look a bit better. So you can see I now have a range that generates this. Python will not give you this. So if you are looking for a place where you use Python, you have to solve it yourself. You have to by understanding computational thinking, understanding certain programming concepts, then will help you to actually generate this. Otherwise, you could and start. Of course, you can do something and start to do all kind of stuff. But the good thing with this generator is that you can now use it all throughout your code. Okay. But if you are writing something, of course, you can write this without using a generator. You can write something that can give you this, but it will not be as efficient as this. Okay, it will not be as efficient as this. For instance, now why this is more efficient is because if I try to print out this, for instance, let's print out and see what will happen. Okay, you can see it's also a generator. Okay, a generator is way more efficient than having a function. So if you now go and write a function, of course, all the values will be generated all at once, and it will feed the memory. But in this case now, you now have only one memory space that whenever you now need the value, to now on the go, it will now be generated as you go. So it's more like pay as you go. All right. So here we're going to end here, and if you have any question, please you can ask. But we're going to still go deeper into it, because I was just trying to introduce us to certain programming concepts that eventually will help us to really write very, very efficient code. we write code in a very senior way. Yeah, so we're going to go deeper into iterators, iterables. So we really understand what this thing means, because obviously I'm sure most of you don't really understand what this is. Okay, what is happening inside there? Like when you have just normal range like this, what exactly this is it? Okay, so we're going to explain that and really learn how to even write our own. Like in this case, this is our own, and this is one I've written that you can then use anywhere. And then if you're now looking for a range of values for, I'll just call it float range in this case. It doesn't exist in Python, so you just write your own. So you can write your own and write in it. You can even, yeah. So there are so many things we can do when we have the tools now. Okay, and then